Good afternoon, everyone. Candidates, good afternoon. I want to welcome you back to mathematics class. And today we are going to learn about differentiation. This is from 4 mathematics. We are still continuing with the syllabus. As I said earlier, that despite the challenge of Corona, we will still continue learning. So you as a student, I want to welcome you. Can you find a comfortable place to sit? Have a pen, find a paper, so that we are going to learn. So we are today we are going to learn chapter 8 of Form 4 syllabus about differentiation. And we have 10 subtopics that we are going to learn on this topic of differentiation. And one is on average and instantaneous rate of change. Average, you remember that we learned gradients in Form 2. So we are going to learn more of gradients in these parts. Then we move on to gradient of a curve at a point. At a point. In Form 2 we learn about gradients between 2 points when we are using a straight line to find the gradients. But at this point we are going to learn gradient of a curve. So we are going to draw some curves, then we are going to find gradients at a point, at a specific point. Then we move to gradient of y equals to x raised to n, where this n is a positive integer. Then we move on to delta notation. Then we move on to the derivative of a polynomial. You remember that in Form 3 we learned about polynomials, where we are expanding polynomials. So we are going to see derivative of these polynomials. Then the sixth one is going to be equations of tangents and normals to a curve. Equations of tangents and normals to a curve. We are going to learn more about what is an equation of a tangent and what is normal to a tangent, to a curve. Then we have stationary points, turning points. We are going to see about turning points in these stationary points. Then we are going to also sketch some curves. We are going to learn on how to properly sketch a curve. Then application of differentiation in calculating velocity and acceleration. So we are going to use this differentiation. We are going to see how we are going to use this differentiation to calculate velocity and acceleration. Then the last part is finding maxima and minima. So welcome to the class. By now I'm very sure that you are ready to learn. So can you make yourself comfortable? We are going to use this. We have only one board, a small board. Don't mind about our small board. We are going to learn more. But differentiation is the easiest topic in mathematics. In fact, it is more interactive, it is more enjoyable, and I know most of you are going to enjoy this lesson so much. You are going to enjoy it because differentiation is so easy, it is so practical, and all of us are going to learn in that manner. So so today's date is date 18 May 2020, and we are going to start from this first subtopic, and we are going to add the average an instantaneous rate of change. In book 3, there are some of the things that we learn about gradients. And we say that the gradient of a curve at a point, the gradient of a curve at a point, we have our curve, then we find the gradient at a particular point along that curve. Is the gradient of the tangent to the curve at a point, is the gradient of the tangent to the curve at a point. So we are going to consider we are going to consider this curve x y equals to x raised to 2. So we are going to just have a sketch of this. This is the y-axis, this is the x-axis, there is our origin, and we are going to have our curve when this one is 1, 2, 3, 4, -1, -2, -3, 1, 2, 3, 4, 5. So we know that when this one is, when we have y equals to x squared, it means in our table we're going to have x and y. We're going to start maybe from -3, -3, we're going to have -2, -1, 0, 1, 2, maybe 3, so that we have 9, 4, 1, 0, 1, 4, 9. So can you make sure that you have this this table, because I'm going to rub here. So we can start from this point where we have 3. Here is going to be 6, 7 as you proceed. So you can see we don't have, it's not enough. Our board is so small and we cannot have all the points. But using your graph paper, I know you are able to find all the points. So we can move on to 3. We can start from these points. From 2 we have 4, where we have 1, 1. We have our origin. We have -1, 1. We have -2, 4. Then we have 3, 9. So it's going to slope from that point. So we have our curve moving from that point upwards. So we are going to have, as it proceeds to this point, 3, 9. So we have our curve as x squared. That is our curve. That is just a rough curve. So I want us to find the average rate of change between these 2 points. I want us to find average rates of change between x equals to 1 and x equals to 3. So where we have x equals to 1 and x equals to 2, we are going to have the points. We are going to have the points. So x equals to 1 is here along the curve. So we can name it here P. Then x equals to 3, 8, 9, we can have our points here, so that continuation, so that we have our point here Q. That is our point Q. So that let us find the gradients. So we want to find the average rate of change between x equals to 1 and x equals to 3. So this means that we are going to get the points, the gradients of PQ. That PQ. So this means that PQ, and we know gradients, we are going to say change in y over change in x. So we will have change in y, change in y. Change in y, we have 9 minus from this point. So we have 9 minus 1 over change in x, which is 3 minus 1. What are we going to get? 9 minus 1 equals to 8, and this one is 2, meaning our gradient is going to be 4. So 4 is our gradient of the average rate of change between these 2 points, x equals to 1 and x equals to 3. So also the rate of change of a curve. We want to find the rate of change of this curve when x equals to 2. Rate of change the curve when x equals to 2. When x equals to 2. So we are going to have that point x equals to 2 along this curve at this point. Remember that it was average and instantaneous rate of change. So we are done with average. We want to find the rate of change of the curve at a point. So for this case, we have our x as 2. So we are going to have that our x as 2. Then we draw a tangent to the curve at this particular point. So a tangent is a line which is going to touch only one point along this curve. Only one point along this curve. Only one. Only one point along this curve. So that we have our tangent so we are going to if you are going to draw, then you realize there is a this tangent, this line is touching this curve at this point. It's touching this curve at that point. Make sure you draw, have your time. Make sure you draw a good and a smooth curve, so that when you draw this line, this tangent line, it's going to touch only one point along this curve, and that point should be where x equals to 2. Remember that here is our x equals to 2, so you just follow that point here, then you draw that line which touches only one point of this curve. Then after finding this, then you will find the gradient of this tangent. Remember that we said when you have your line going that way, then you can find the gradient by finding the change in y divided by change in x. So it's also the same to this. You are going to find change. You are going to find change in x or change in y over change in x. And these are my points that using my graph. These are the points. So I have the points, the first points of the curve being where we can change in y over change in x, 8.1 minus 4 all over 3 minus 2. So find, you know that gradient is the same along this straight line, but it is not the same along this curve. But now we are using a straight line to find a gradient at a particular point along this curve. That is why we are, despite the digits that you get, or the numbers that you get in along this, or the points that you're going to use along this line, the gradient is going to be the same because you are using a straight line. That is why for my case, I have 8.1, that is changing from 8 somewhere here, 8 points. So the difference between this point and this point is the same as this, from here to here. So it is changing x. So I have here is 8.1 and here is 4. So that is why I'm finding difference. Then we have here from negative 3, or 3 and 2, these points. So here the difference from here to here is 1, while the difference between 8.1 and 4 is going to be 4.1. So we are going to have going to be 4.1 divided by 1, which is going to give us 4.1. So this is the rate of change to the curve, rate of change, or the gradient of this point. This is the gradient of this curve at x equals to 2. So as the curve slopes down, the gradient keeps on changing. It's not the same. The gradient at this point is not the same as gradient at this point. Also, it is not the same as gradient at this point. This is not also the same as gradient at these points, origin points. Then as it moves, but for now we have where x equals to 2, the gradient at this particular point is 4.1. That is what is known as instantaneous rate of change. Instantaneous rate of change. So I want us to move to another example where we have the same. This is an exercise. I want you to draw y equals to x squared, or x raised to 2. Another curve which is the same as this one. Then you draw, or then you find the average rate of change from. So the first part is average rate of change between x equals to 0 and x equals to 4. Where we have x equals to 0 and x equals to 4. Then we move to rate of change, the rate of change from, or the instantaneous change at a point. Instantaneous change at a point. Change at a point. and our point is going to be 2, 5, x equals to, where x equals to 2.5. So that's our question. The first one is going to be average rate of change between these 2 points. Remember that you're going to draw this curve, then you identify these points where x equals to 0 and x equals to 4. X equals to 0 and x equals to 4. So you are going to have that line from this point to where that curve is. Then you find gradients, that is change in y over change in x. Then you have your own gradient. Then now you move to b, instantaneous change at a point where x equals to 2.5. So between the two we have 2.5 here. So you're going to have that point. Then you draw a tangent to that point, to this curve at this point. Then you now find the gradient. That is where you are going to find the rate of or the instantaneous change at a point. So here is a question. I'm going to give you 2 minutes. Can you have a try? Can you give it a try? So that we are going to continue to the next subtopic. So we are moving on. We are moving on to gradient of y equals to x raised to n, where n is a positive integer. You still remember integers, and this n is positive. It's not negative in this case. So we are going to take this n as our, so it is y equals to x raised to n, and n is our positive integer. Now there is one concept that I want us to just go through here. It is this: when we have our curve, that is our curve, then we have 2 points P. This one is y and this one is x, and here is q. Then we have this line here. We will realize that this one is between 2 points. When we want to find gradient between the 2 points, when you realize that when we move these points to another q1, when we also move to another point q2, we will realize that the change here as you move downwards to this point P, to a point where we are going to have that point P. As you move this line closer to point, as you move point Q closer to P, the change is going to be sufficiently small. The change is going to be sufficiently small. If you find the difference, if you are going to calculate and see, if you are going to have like from point 2, 4, like our point 2 and 4, that is position of y and 4, that is our 4, and then you try to find what is the gradient. What is the gradient? You'll realize that the difference or the gradient is going to have a small change. It is going to change the difference between the gradient between this point at this point and this point at this point and this point at this point keeps on reducing to a point where the change is so small that we can just ignore. That is just how to give you an idea, so that we are going to use it in this part. So So we want to find the gradients of y. We are still on y equals x raised to 2. That is still our curve, and we are going to have these points of where we have the gradient of the curve y equals to x, and our general points, you always know that we always give as x, y. That is the coordinates of a gradient of a point, of plotting a point. This is always the coordinates. So we are going to have the gradients of this where we don't know. This, for this case, this is the unknown. So we are going to factor in a small change. We are going to bring in a small change in the value of x. And for this case, we can have our coordinates as, in general points, we can have our coordinates as x equals x raised to 2. I'm very sure you are aware this y is the same as this. That is why we are putting this way. So that is the points that we are going to do, because we want to use only x. We want to use only x. So we are going to bring a small change, and we are going to let small change or small increase in x be h. So we are going to let a small increase in value of x coordinates to be h. So our new coordinates, this is our previous coordinates where we had x into x squared. It's going now to move to x plus h to x plus h squared. Remember that is a small increase in the value of x. That is why all this is y. Remember that it was x squared, but now there's a small increase in x, which is h. That is why we say x plus h, all of them is squared. So all these are new coordinates, so that we are going to have these points here. This is our origin. That is our, so that we have our curve. This one is y equals to x squared, and we have 2 points. This is our point P, and this is our point Q. And we know that our P is going to be x squared. This is the same as y. Remember that we say y equals to x raised to 2. So we replaced y with x squared. We replaced y with x squared. That is why our new coordinate now is going, not new, but x to x squared, which this takes the position of y. So that our new point now is this one, where we have x plus h to x plus h. This one is squared. I hope you are seeing this. These are our new points. These are our new points. That is why we have x plus h into x plus h. Then we close the brackets as we square, because all this, as I did explain earlier in these points. So we have the two points. I want us to join the 2 points. Then we now find the gradients of these points. And you know that the gradient of these 2 points is change in y over change in x. Change in y over change in x. So the gradients of PQ is going to be change in y over change in x. And for this case, are you able to identify change in y, where we have the 2? So we are going to have x plus h, all of this squared, minus x squared all over x plus h minus x. So when we open the yes, we're going to continue. When we open the brackets, remember that how to open brackets is x plus h. It's like x plus h, x plus h. So that is x into x plus h plus h into x plus h. So that we are going to have x squared plus xh plus xh plus x squared. So for this case, this one is going to give us 2xh. So we are going to have x squared plus 2xh plus h squared. All of this is an expansion of this. Remember how to expand? Then minus x squared all over x plus h minus x. So as you can see, we have positive x squared and we have negative x squared, meaning these two are going to cancel out. Then also this one and this one is going to cancel out each other. So we are going to remain with 2xh plus h squared all over h. So we want to cancel out the denominator. We are going to have h into 2x plus h all over h, so that we cancel out this one to remain with 2x plus h, to remain with 2x plus h. That is our gradients of these 2 points P, Q. That line now represents the gradients of this equation y equals x squared. And as I explained earlier, we talked about a small change which we represented as h. And for this case, the h here represented a small change in the value of x. And I said that we are going to ignore that small change because it is sufficiently becoming smaller. That is why we are going to ignore and remain with 2x as our gradients of this question. So our gradients, the gradients of the equation y equals x raised to 2, its gradients equals to is equals to 2x, because this is the gradient of that question. So, and for that case, we are going to have a conclusion of this, and we are going to say that when we have the gradient function given as y equals to xn is given by this. Now, this one is known as gradient function. This the solution of this is known as gradient function of y equals to x raised to power 2. So this one is known as gradient function, and we are going to say gradient function of y equals to x raised to 2 is 2x. So the gradient function of the gradient function is 2x, and that is why we have that part, or it's also known as the derivative function, or the derivative or derived function. So those are the terms. Remember that we ignored h. We have our derivative or our derived function as 2x. Now there's a challenge that I may not know where you as a student has not understood, because now I'm here alone. Back there at home, maybe you have some questions or where to clarify, but this is how it should be. So it is known as derived function, derivative, or the gradient function. So they have three names. So, and in general, I want you to have this. When we have y equals raised to n, y raised to n, the derivative of this question is going to be n x n minus 1. I want you to see this clearly. As you can see, this power n is being brought here. Then you less this power by 1. That is why in that case, where we had y equals to 2 equals to x raised to 2, as you can see, we brought this 2, then we say x2 minus 1 to get 2x, because this x raised to 1. So this is the concept, which is, so this is our derivative or derived function or gradient function. So if we had y equals to x raised to 3, so we are going to say 3x raised to 3 minus 1 to get 3x raised to 2. How about if we had y equals to x raised to 5? This one is 5, so we got 5x raised to 4. That is how it should be. We less 1 from n. So I want you to have this question. These are questions. 1, I want you to find, can you differentiate? The process of doing this is known as differentiation. the process of finding derivative, the process of finding gradient function, this process of bringing this n here, then we less 1 is known as differentiation. So when I say can you differentiate y equals to x equals to 5, so this is your answer of that differentiation. That is why I want you to have these questions. I want you to derive this y equals to x raised to 10 to y equals to x raised to negative 5. This one is negative 5. Negative 5. So I want you to find differentiation. Can you differentiate? Can you find the derivative of that part? So we are now at delta notation. Remember that we said a small change. We let small change be the h. For this case, I want us to introduce the term delta. Delta. So it's given by delta x, or it is a Greek word, or it's a small, in a small letter, it is written this way to represent delta x, or we can just say dx. So these are the terms that we're going to use to represent delta. So we have 2 points here. We have 2 points, that is point P. We have this equation first, before we talked about the points. We have this question where we have y equals to a, where a is constant, x raised to power of 2. So I want us to find the derivative or the gradient function of this question. So we consider these 2 points, point P, where we have x squared. Remember that this is the value of y. Then we have these two another points x, where now we have a small increments, and this small increments, we are not, this round we are not going to use x, we are going to use delta x. So we are going to have our x plus delta x into x plus delta x squared. So those are the two points that we are going to use to find the change or to find the gradient of these two. So I know you can give a try. You can just start doing that, and we are going to find derivative. So we are going to find the dy dx. We are going to find dy dx of the 2 this one we are going to find, it is known as derivative. We can use this one, derivative. We can also use delta y over delta x, or we can just use that one to mean this is derivative or process of differentiation. That is the process of differentiation. We can find derivative using dy dx. We say that we are differentiating y with respect to x. We are differentiating y in respect to x. So we are going to use one of them. So let's say dy over dx is going to be change in y of a change in x. So as you can see, we are going to find the difference between the y's, then the difference between the x. So we are going to say a into x plus x squared, no, not x equal, minus a x squared divided by x plus delta x minus x, that way. So because we are using delta here, we can also, we say they are the same, so it is the same as delta y over delta x, so that it's not going to bring confusion to you. So that is how it should be. So we are going to open this one, and we're going to have a into x squared when we open this bracket plus 2x delta x plus delta x squared minus a x squared, so that when we open this bracket, we are going to have a x squared plus 2ax delta x plus a into delta x minus ax squared. So you can see this one and this one is going to cancel out, divided by, we have it here, so this one and this one is going to cancel out to have delta x, so that we are going to remain with 2ax delta x plus delta x squared over delta x. So you can see both here we have delta x, so we are going to say 2ax plus delta x. We have our delta x here over delta x, so that this one and this one is going to cancel out to remain with 2ax plus delta x. And also we are going to ignore this because it's a small change which is sufficiently going to be ignored. So we will remain with 2ax as our derivative. So we will have this part as our 2ax because we ignore this one. This one also will bring us to a general formula or general information that we have ax raised to n, ax raised to n, or before that one we can have this, yes, so that one is okay. You can also use this one. Let us use this before we conclude. We have y equals ax raised to 2. So as you can see, we are going to say we have 2ax, that is our derivative. When we differentiate this one, we have this. You can see 2. Remember the concept of bringing 2, these are points, giving us a general knowledge that when we have this one, then we are going to have n a x into n minus 1. That is our general that is our general formula. The derivative of the sum of a number of terms is obtained by differentiating, or I can say the derivative of y equals to ax raised to n is nax raised to n minus 1. That is our delta notation. So I want you to differentiate this. Can you differentiate these parts? These are questions. 1, I want you to have this y equals to 4x raised to 3. 2, y equals to negative half x raised to 12. This one is 12. This one is 12. So can you find the derivative of that one using this concept I've given you here? So you can have all those questions. I'm giving you 2 minutes. Can you try? Can you attempt? So that we are going to have so we are the derivative of a polynomial. Remember that. You still remember the polynomials in form 3. We say these are constants. A are constants, and as you can see, when the value of a is increasing, the value of x, the power of x, is decreasing. So these are polynomial, and we have also an example of y equals to 4x squared plus 3x plus 12 is another, as it's that way, it's a polynomial. So we have this equation of y equals to, or a curve of y equals to x squared plus 3x plus 12. We want to find its derivative. And now, after knowing that, when we have y equals to ax n is going to give us n a x n minus 1, then we are going to use this also to derive or to differentiate y in respect to x to find the derivative of this. So we are differentiating differentiating with respect to x. So we are going only to have to differentiate where we have x, and for this case we are going to have 2. We are bringing 2 multiplied by this 4, then x raised to 2 minus 1 plus we have 1. This here is 1, so it is 1. It is 1 into 3 into x1 minus 1. That point. So we'll have here is 8x plus 3 x plus 8x plus 3. The reason is why the reason is this: any number raised to 0 is equivalent to 1. We know that. So that is why we have 8x plus 3. That is how to find a derivative of a polynomial. So we can have another example. Here of y equals to x raised to 3 minus 2x raised to 2 plus 7x minus 4. So we're going to say dy over dx equals to 3x 3 minus 1 minus 4x 2 minus 1 plus 7. So we're going to have 3x raised to 2 minus 4 raised to x plus 7. That is our answer. So when you're told to differentiate a certain equation of a curve with respect to x, this is what you're going to do. At times you're given like this example here, and I'm looking out at this example here, where we have y equals to x plus 2 into x minus 1. So what you do here is you just expand to have x squared plus x minus 2, so that now you say dy over dx equals to 2x plus 1. So that is your answer. So another question is differentiate 1. The first one is y equals to 3x raised to 4 plus x raised to 3 minus x. 3x raised to 4 plus x raised to 3 minus x. We have also another one where we have y equals to 4x raised to 2 plus 3x plus 12. So the 2, y equals to 4x squared plus 3x plus 12. Can you differentiate that one with respect to x? Then we are going to continue from that point. So we are moving on to equations of tangents and normals to to a curve. Remember that we say the gradient of a curve is the same as gradient over tangent to the curve at a point. The gradient of a curve, when you have our curve here, the gradient of this curve is the same as gradient over tangent to the curve at a point. At a point where we have that, this is a point. The gradient of this curve is the same as gradient over tangent to a curve at this point. That is why when we want to find the equation of a tangent to a curve, equation of this tangent to a curve. Remember, tangent is a straight line. So we want to find equation of these tangents, and we are given the equation of this curve, and we are also given the points of contact between the tangents, the line and a curve. That is why it's known as a tangent. So we have y equals to, I'm going to start at this corner. We have y equals to x raised to 3 plus 2x plus 1 at 1/4. So this is the equation of a curve, and we have a line which is touching this curve at 0.14. So we want to find the equation of that line. So what we're going to do is to differentiate this, where we are going to say dy over dx equals to 3x squared plus 2 sorry. So this is our this is our we've differentiated, and we have our gradient function here. So we are going to say, we are going to have this, to have the gradient, to find the gradient of this line. We are going to replace this value of x here with this one, with the gradient function, because we have gradient function here. So to find gradients, we are going to say 3 into 1 squared plus 2, which is going to give us 5. So, and remember that to find an equation of a straight line, we need a point and a gradient. So we already have a gradient and we have a point, which is 1, 4. So what we have to have is that it is change in y over change in x will give us gradient. That is why we are going to say y minus 4 over x minus 1 equals to 5. So that we're going to have y minus 4 equals to 5 into x minus 1. So that we're going to have y equals to 5x yes, 5x minus 5 plus 4. So that we are going to have y equals to 5x minus 1. 5 equals to x minus 1. So this is the equation of our tangent. Equation of a tangent. Equation of this line. Equation of our tangent. So that is the question. So when we move to normals to a curve, it means that we have another line which is perpendicular. And that is where we have normals. So when you hear normals, it is a perpendicular line to a tangent to that curve. So that we can also find the equation of this normal to a curve. Because we said gradient m1 multiplied by m2 will give us -1. Meaning we have the first gradient, which is 5, 5 m2 equals to -1, meaning our m2 is going to be -1 over 5. So we have our points, we have our gradients, and we have our points as well, because they are meeting that particular point of tangent. So we are going to say change in y is y minus 4 over x minus 1 equals to -1 over 5. So we are going to have 5 into y minus 4. When we take 5 the other side, then we are going to say -1 into x minus 1 to have 5y minus 20 equals to -x plus 1. So we are going to have 5y equals to -x plus 1 plus 20. Are we correct? Are we really correct? So that we are going to have divide by 5 to have y equals to -x plus 21 all over 5. So this is the equation of a normal to a curve. So we've said finding equation of a tangent is that you are going to derive this one, then you replace that, then you replace the value of x here with the value of x at a point, then you find the gradients, then you now have your equation of a line. And when you move to normal, is that it is perpendicular. The normal is perpendicular to tangent to that curve at a point, and that is how you're going to do. So I want you to find equation of a normal to a curve, this curve. Question, I want you to find this. Y equals to x raised to 3 minus 2x minus 1 at point 1, -2. So y equals to x raised to 3 minus 2x minus 1 at 1, -2. So find equation of tangents and normal to a curve, the two. Welcome back. We are still on differentiation. We are now at stationary points. And consider this curve, y equals to x squared plus 2x plus 3. We want to find the nature of the curve. So we are going to differentiate this one to have dy over dx where we are going to have 2x plus 2, because that is our derivative. So what you have to note here, is that at turning points is where we have our dy dx as 0. We are going to see the nature of this curve. If it is going to have that way, then here is our turning point, and this one is going to give us maximum. If it's going to behave that way, then here is our turning point, and this one is going to give a turning point is going to be minimum. Well, if we are going to have this one is our point, is known as point of inflection. Point of inflection, because it is rising. It is not rising, then flat, then drops. That is known as maximum. Where it drops, then it slopes, then it again rises. That one is minimum, and this one is point of inflection. We are going to see all this here. So what you have to note here is that dy over dx is 0 at stationary point. This is the stationary point. Here, dy over dx equals to 0. dy over dx equals to 0 at those turning points. So we want to find the value of x at this point, a turning point. So we are going to say we are going to equate, of course we know it is equal to 0. So we are going to say 2x, we're going to say 2x plus 2 equals to 0, which is the same as 2x equals to -2. So our x is going to be -1. Our x is going to be -1. So there's a table we are going to prepare. Here. And this table is that we are going to have here x, and we have here gradient of x. Gradient, not y. Gradient of x. And we know that we are going to use this one to find gradient, because it's a gradient function. So we are going to use only three points. We are going to use the turning point where x is -1. Then we use left to see the nature of this. We can use 0. And also the right hand side, we can use the left of this is not 0. The right of this is 0. then the left of this is going to be negative 2. Negative 2. So we are going to replace it here. We are going to replace it with this. We are going to replace it with 2x plus 2. So when we put 0 here, 0 plus 2, we are going to get 2. So we'll have 2 here. When we put here 2 into negative 2 plus 2, we are going to have negative 4. We are going to have negative 2. There. So here is negative 2. When we put here 2 into, when we put 0, we get 2 here. Then this, I hope you are seeing this correction. Here we have 0, so we put the gradient here. Where we have negative 1 plus 2, we have 2 plus negative 2 plus 2 is always going to give us 0. So at turning points, the gradient is always 0. That is what you have to start with. The gradient is 0, so that you are going to find the gradient at the right, then you find the gradient at the left, at the left, and also gradient at the right. So when you have negative sign in this point, what you have to do is it shows that the gradient slopes. It slopes from left to right. While this one is flat and this one is rising, sloping upwards. This one is sloping downwards from left to right, then this one is sloping upwards from left to right. This point, as you can see, is giving you as such a curve. So this one is minimum. So the nature of this curve, the nature of this stationary point is a minimum point. This one is a minimum point. So this curve, you are going to see it's behaving that way, so that the nature of this gradient, dy over dx, is a minimum point. So we are going to move to another one, so that we have another example here. Of y equals to negative x squared plus 4x plus 2. So what we said is that we are going to find dy dx of this. Dy over dx is going to be negative 2x plus 4. So the value of x of this, we are going to say negative 2x plus 4 equals to 0, meaning 4 equals to 2x. Our x is going to be 2. So the value of x is going to be 2, the same as this. For this case it was 1, and for this case is 2. So we are going to have the same table where we are going to have gradient of x. We are going to have 2 here, and also its gradient is 0. You said turning point, so stationary point, the gradient is 0. So the left of this, you are going to have 1, then this one you are going to have 3. Any point, as long as it's on left or right of this point x. So we have this. We have negative 2 into 1 plus 4 to have what? This one is negative 2 to have 2. So here we have 2. It is rising. This one is sloping. Always at where we have 0 as gradient is sloping. Then we have this one 3. negative 2 into 3 plus 4, we'll have, this one is negative 6, we have negative 2. So negative 2 sloping downwards. This one is going to give us maximum. This one is minimum, and this one is maximum. That is how to find all this. So this is just but one example, so that you're going to have enough time to move on. But there are so many questions that you have in your books. There are so many questions you have in your papers, but the concept is this. So make sure that you capture the content well. So the concepts that we are teaching you here, so that you're going to use to apply in answering your questions. So we are moving to another one, where you are going to have points of inflection, and we can have this curve y equals to x minus 4. So what is the derivative of this? Or that way. So if you are going to have that one equals to 0, what is the value? What is the value of what is the value of x? What is the value of x for that case? So you're supposed to find the value of x. The first value of x is 0 for that case. So that now when you have your table here, x and your gradients, we have here 0, you have here negative 1, you have here 1. We can say that is going to give us 0. We can have 3 into 1 into negative 1 squared. This is going to give us 3. It's going to give us 3 rising. And this one is flat sloping. Then we have 3 into 1 giving us another 3. So we'll have this one is point of inflection. We can have another table in another example that you are going to find. So you have values of this, then you get negative 0, negative, meaning sloping, flat and sloping. Also this one is known as points of inflection. Another point of inflection. So the two are giving us the points of inflection. The two stationary points are giving us points of inflection. So this is your question. Identify the stationary points. Identify the nature of the stationary points. We have y equals to 2x squared minus 4x plus 3. That is 1. 2 is y equals to x raised to 5 minus 9x raised to 3 plus 3. The two examples are good for now, so that you're going to have the nature of that. We can add another one because there are 3 points of the inflections. Stationary types of, there are 4 actually, but I want us to see maximum, minimum, and point of inflection. So we can have y equals 2x raised to 3 plus 5. So the three questions is going to serve you well. So have a good try at the 3. Make sure that you rewind the video to see if there is somewhere that you didn't understand. And as I said, if you have any question here, you can just forward those questions to me. Otherwise, that's 3 minutes we are going to use to answer the 3 questions. So we are now at curve sketching. We are going to consider this curve of y equals to x squared minus 6x, and we want to find the turning points of this. We want to sketch, and sketching a curve, we only interested in the important features of a curve. The points where it's going to cut x-axis, the point where it's going to cut y-axis, and the turning point. All those are the important features in curve sketching. So what we're going to do here is to have dy over dx equals to 2x minus 6. So what is our turning point? What is the value of x in our turning point? So we are going to say 2x equals to 6. So our x is going to be 3. So the value of x is going to be 3. How about y? If x is 3, then how about y? So y is going to be 3 squared minus 6 into 3. We'll have 9 minus 18. We'll have negative 9. So the turning point of this is at point 3, negative 9. So that is our turning point. While here, we want now to see where it cuts x-axis. Where it cuts x-axis is when y equals to 0. That is where it cuts x-axis. So we are going to say 0 equals to x squared minus 6x. And for this case, 0 equals to x into x minus 6. So the first value of x equals 0, another one equals to 6. So we are going to take this one, 6. Then how about when x equals to 0, this is y axis, we are going to say y equals to 0 raised to 2 minus 6, 0. So we'll have y equals to 0. So when we are going to have that sketch of the curve, sketch of this curve, at y-axis, we have y as 0, so it's here. We have at x-axis, we have x as 6, so 1, 2, 3, 4, 5, 6 is here. Then we have our 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is here. Then we have our sketch that way. That is just but our sketch. I know it's not uniform. I know it's not appropriate that way, but just a sketch so that you are, while use a squared or a graph paper to have exact sketch of that. So I want you to, this is your question. This is your question. I want you to sketch this curve where we have y equals to 2x squared minus 4x plus 3. Can you scale that? Can you scale that half? We want to find the application application of differentiation in calculating velocity and acceleration, and we are going to start with velocity. And when we want to find velocity, we are going to differentiate displacement in respect to time. So in finding velocity, we are going to say ds over dt. So consider this question: displacement. There's a particle, or there's the displacement s meters covered by a moving particle after time t seconds is given by this. So this is the displacement is given by 2t cubed plus 4t squared minus 8t plus 3. So that is the displacement, and we want to find velocity. Find velocity at when t equals to 2 and t equals to 3. That is A. And also we want to instant at which particle is at rest. Instant at which particle is at rest. So we want to find the velocity when time is 2 seconds. 2 seconds. We are given time in seconds, and displacement in meters. So we are going to find the velocity before we move on to instant at which particle is at rest. I hope you know at rest. What does that mean? Meaning there's no movement. So what we're going to do here is to differentiate this. So we are going to say ds over dt equals to 6t squared plus 8t minus 8. So that we now have when time is 2, then we say 6, or when time equals to 2, then we say 6 2 squared plus 8 2 minus 8. We will have 4 24 plus 16 minus 8, which means it is 24 plus 8, which is going to be 32. So we'll have 32 meters per second, because it is velocity. This is what we are looking for, velocity. When time equals to 3, we are going to have 6 3 squared plus 8 3 minus 8, and when you calculate that one, you are going to get 70 meters per second. So when we want to find velocity, in simple terms, when you want to find velocity, what you're going to do is to differentiate displacement in respect to time. Yes, then instant at which particle is at rest, that is B. Particle is at rest. After how long is it going to take for this particle to come to rest? So at this one, we know that velocity at that point of rest equals to 0, meaning ds dt equals to 0, meaning we're going to equate this one to 0. So we'll have 6t squared plus 8t minus 8 equals 0. So what is the value of t? So we'll have 2 into 3t squared plus 4t minus 8 equals 0. I know you know how to find this one using any method, and we are going to find that it is going to be 2. So time is going to be 2 all over 3 seconds, or time equals to negative 2. Definitely we are going to get two values of t because of this nature. So we are going to ignore this because we don't have time in negatives. Then we are going to take time equals to 2 all over 3 seconds. 30 seconds, the time of rest of this particle. When you throw that particle, there's a distance is going to move. There's a time going to take for it to come to a total rest. And when you have total rest, it means velocity is 0. And this is how you are going to find the time at which, instant at which the particle will come to rest. That is on velocity. Then we are going to move on to acceleration, because we are on application of differentiation in calculating velocity and acceleration. We are now at acceleration, and to find acceleration, we are going to differentiate velocity in respect to time. So we have this: a particle moves in a straight line. Say that velocity v meters per second after t seconds is given by this. Velocity of this particle is going to be 3 plus 10t minus t squared. So this is the velocity of this particle moving in a straight line. So we know that to find acceleration of this, we are going to differentiate this one in respect to time, which is t. We are going to have 10 minus 2t. We are going to find that one, 2t. Now the question is, find acceleration. Find acceleration at t equals to 1 second and also t equals to 3 seconds. That is the question of this, what we have to answer in this question. So we have this. We are going just to replace, to find acceleration, is that 10 minus 2, we are going to replace with 1, so that we are going to have 10 minus 2 equals to 8 meters per second square, because it is acceleration. So that is what we have to get there. So in this other side, we get 10 minus 2, then we replace this 3 here to get 10 minus 6, we get 4 meters per second square. That is how it should be. In finding acceleration, we've said we differentiate velocity in respect to time. So again, another question. This is part A. This is A. Then B is instant at which acceleration is 0. Instant at which acceleration is 0. So you know that you are going to equate this one with 0. dv over dt equals to 0. Meaning we are going to say 10 minus 2t equals to 0. Meaning 10 equals to 2t. T is going to be 5 seconds, because it is time. So our time was in seconds. So time at which acceleration is 0 is after 5 seconds. 5 seconds is at point where acceleration was 0. No increasing, no decreasing of this particular particle. So that is the question. So I want to give you maybe one to read to you, so that you are going to or let me just say, if you have exercise of this book, KLB Mathematics Book 4, if you have this exercise 8.5, number 1, 2, 3, and 4 can serve you good. Now, I'm going to read you one, that is number 3, so that if in case you don't have the book, you're going to use it. It reads, the velocity v meters per second of a particle moving in a straight line after t seconds is given by v equals to t minus 7t squared, where t is the time in seconds. Calculate A. Can you calculate? The part A is the acceleration at t equals to 2. That is part 1. 2 is that t equals to 5. Then part B, because this one is A, part B is that the instant at which the acceleration is 0. The instant at which acceleration is 0. That is on acceleration. Then another question, question 1, that was question 3, so you're going to take as question 1, and then this question 1 you're going to take as question 2. I'm going to give you here. It reads, a stone is thrown vertically upwards. A stone is thrown vertically upwards such that its height s meters above the ground after t seconds is given by s equals to 40t minus 10t squared. 40t minus 10t squared. Find A. Its height above the ground after 2 seconds. After 2 seconds. After 2 seconds. The height above the ground after 2 seconds. B. Its velocity after 1 second. Its velocity after 1 second. C. The instant at which the stone is 30 meters high. The instant at which the stone is 30 meters high. 30 meters high. So that one is the question. So I want us to leave our differentiation of that particular point. We'll still continue revising. There are so many questions that I know you have. There are so many concepts that we can still learn, but all these are our basics. I want you to continue learning. Don't tire following this video. It will help you so much. I want to wish you all the best, all the candidates in Republic of Kenya and any other part of the world, if it is relevant. I'm not aware if all this mathematics is relevant elsewhere to the other candidates, but if you find it useful, then I want you to try and practice as much as you can. So what I have to say is that all this is being done because of this pandemic. We would have been using a good materials, but don't mind. The concept is that we learn mathematics. Mathematics is very simple. So I want to wish each and every one of you good night, and sanitize, stay at home. Bye.